In this video, we'll talk about very specific kind of exponential equations, the ones we can solve directly. Let's take a look at this one. 3 to the power of x equals to 81. Now, if we can bring them to the same base, that's one technique we can use. For example, 81 is the power of 3. If you recall, it's 9 squared, which means it's 3 to the 4th power. So if we set them equal to each other, since the bases are the same, that means the exponents are also the same. So that means x is 4, and that's our answer. Let's take a look at more challenging example. How about this one? 2 to the negative x plus 1 equals to 16. Now note, 16 is also a power of 2. In fact, it's 2 to the 4, very much like the previous example. So if we set them equal to each other, then we can proceed in the same manner. We can set the two equations equal to each other, the two exponents, and we can solve for x very much the same way. So let's take a look. And we get x equals negative 3 as the answer. Let's take a look at one more example. What about if we have exponents on both sides? 2 to the x equals to 4 to the 2x plus 1. Now, if we have exponents, now 4 is also a power of 2. However, we'll have an exponent raised to another exponent. If you recall this rule, which means basically we have y times of a to the x. So it's a to the x, a to the x, a to the x times y times. So that's actually the same as a to the x times y power. We multiply the exponents. We can apply the same rule here. So if we set this up correctly, we bring it to the same base, and then the next step, we can distribute the 2 very much based on the rule. So we're going to have 4x plus 2 on the right hand side. So we basically distribute the exponent. And then we proceed as usual. We set the two exponents equal to each other and we solve for x. And we proceed to find the answer, which happens to be negative 2/3. And that's it.